Good day everyone. Today I will be presenting our AVL3 Python implementation designed to help address a challenge from SDG 12, which is reducing food waste. Let's dive into the code. First is the food item class. This class represents a perishable food product. The first method, which is init, initializes each food item with its name, quantity, and expiry date to be managed in the AVL tree. The next method is string method. It returns a string representation of a food item displaying its name, quantity, and expiry date. This aids in debugging and inventory visualization. Next is the AVL node class. This class represents a node in the AVL tree. The init method creates an AVL node that stores a food item along with a key, which is the expiry date, pointers to its left and right children, and a height value, which is essential for balancing. Next is the AVL tree class. This class implements the AVL tree data structure to efficiently manage perishable inventory. The first function, which is the getHeight method, returns the height of a node, which helps determine the tree's balance. Next is the getBalance method, which computes the balance factor, left subtree height minus right subtree height. If the balance is outside -1 and 1, rotations are triggered to rebalance the tree. Next is the left rotate method. This rotates nodes to maintain balance, making the right child the new root and repositioning affected nodes. Next is the insert method. It adds new food items into the AVL tree while ensuring it remains balanced and items are sorted by expiry date. Next is the search method. It quickly retrieves food items based on their expiry date. Next is the min node value method. It finds the smallest node in the subtree, which is essential for deletion when replacing a removed node with its in-order successor. Next is the delete method. It removes expired or sold out items using standard BST deletion logic, ensuring that the AVL tree remains balanced. Next is the in-order method. Performs an in-order traversal, left, root, and right, listing items sorted by expiry date, useful for displaying inventory in a structured format. Next is the food waste reduction system class. This class integrates the AVL tree into a real-world inventory system to manage food waste. First method, which is the init, initializes the system to store and track food items dynamically. The addItem method adds new perishable items, allowing them to be monitored based on their expiry dates. The simulateDay method directly reduces food waste by ensuring that near expiry items are either removed or sold, preventing unnecessary waste. The displayInventory method provides a real-time snapshot of the inventory, helping stakeholders identify items nearing expiration and assess system performance. Alright, that concludes our code walkthrough. This AVL tree implementation efficiently manages perishable inventory, directly addressing food waste by prioritizing timely sales and removal. Thank you for listening.
Everyone, on this section, I'm going to walk you through the program that helps reduce food waste using an AVL tree. We'll focus on how food items are added, managed, and removed from the inventory. First, let's set up our food storage system. We create an instance of food waste reduction system. This system allows us to add food items and track them based on their expiry dates. Now, we add 5 food items with different expiry dates. Each item has a name, a quantity, and an expiry day. The AVL tree sorts them automatically based on expiry dates. Next, we simulate 6 days of inventory management. Each day, the system checks food expiry, sells items nearing expiration, removes expired food, and lists down the remaining inventory. We can see on day 1 that 3 units of bread are sold since they will expire on the next day. The remaining units of bread after the sale is 12. The inventory of day 1 is as follows: 12 bread that expire on day 2, 10 milk that expire on day 3, 8 yogurt that expire on day 3 as well, 20 fruits that expire on day 4, and 5 cheese that expire on day 5. The same is applied for succeeding days. On day 3, milk and yogurt expire. Thus, they are considered a waste and are removed from the inventory, while the items that are expiring tomorrow are put on sale and sold. The quantity and expiration threshold of items to be put on sale can be adjusted as needed. This program effectively reduces food waste by prioritizing sales of items close to expiry and removing expired goods. Thank you.